In this presentation, I'm going to discuss functional connectivity and the complexity analysis of resting state fMRI in pre-adolescents with ADHD. ADHD has been increasingly viewed as impairments among distributed functional brain networks. For instance, the frontal-parietal network, default mode network, and the reward and motivation-related network. In the past decade, nonlinear analysis of neural signals, such as complexity analysis, have been implemented in either healthy or diseased populations. Multiscale entropy measures the randomness and the predictability of a stochastic process and generally increases with greater complexity. Two previous studies investigated the complexity of resting state fMRI data in adults with ADHD. Both reported reduced complexity in the frontal cortical areas. In this study, we combined multiscale entropy complexity analysis with functional connectivity analysis to elucidate the functional alterations present in ADHD pre-adolescents. According to the literature, we hypothesized that compared to the healthy controls, pre-adolescents with ADHD had lower multiscale entropy in frontal parietal network and altered functional connectivity in the frontal parietal network, default mode network, and reward and motivation related network. Due to the lack of previous studies, we did not postulate a hypothesis in terms of the difference between ADHD and the control groups on the association between multiscale entropy and functional connectivity. We used the baseline data from the ABCD study. The final study sample included 63 subjects with ADHD and 92 healthy controls matched in age, sex, and the pubertal development status. Multiscale entropy was computed using the in-house developed Loft complexity toolbox for each pre-processed and denoised resting state fMRI sequence for each participant, a factorial group by sex, a COVA on the mean multiscale entropy in each region of interest was conducted with pubertal development status and the scan site as covariates. The same ACOVA was performed on functional connectivity too. In addition, group comparison was evaluated in terms of the partial correlation between multiscale entropy and functional connectivity conditional on sex, pubertal development status, and scan site. The average multiscale entropy maps for the ADHD and the control groups are displayed in figures A and B. The ADHD group appeared to have lower multiscale entropy than the controls, especially in the frontal area. The ACOVA revealed significant main effects of group in all the regions of interest in the frontal parietal network after Benjamin Hochberg correction. Post hoc t-tests, as shown in figure C, indicated that the participants with ADHD had lower multiscale entropy values than the controls in all the regions of interest in the frontal parietal network. Figures A and B in this slide display the significant functional connectivity for the ADHD group and the control group with Benjamin Hochberg correction for each network. It can be seen that most regions of interest were strongly connected within each network. The ACOVA revealed significant main effects of group at two region of interest edges in the frontal parietal network after correction. Post hoc t-tests, as shown in figure C, indicated that the participants with ADHD had stronger functional connectivity than the controls in the right superior frontal gyrus and the left middle frontal gyrus using the anterior cingulate gyrus as the seed. Figures A and B in this slide display the significant partial correlation between multiscale entropy in a specific region of interest and the functional connectivity at the edge of this region of interest to another region of interest for each group after controlling sex, pubertal development status, and scan site after correction for each network. Compared to the controls, the ADHD group appeared to have less regions that were significantly different from zero. However, Benjamin Hochberg corrected results indicated no significant between-group difference in the partial correlation between multiscale entropy and functional connectivity. So that's my talk. Thank you for your attention.